Okay, hi guys. So in this lecture, we'll be discussing on Reimer-Tieman reaction. So this is phenol. Phenol, when passed with chloroform in basic medium and some heat is passed on, then we get this compound. And later on in the second step, we also pass some H plus. Okay, so simple. So when phenol reacts with chloroform in alkaline medium, formylation of phenol takes place, and this is known as Reimer-Tieman reaction. Okay, so let's now discuss the mechanism behind the scenes. So let's start it. So mechanism would be, we have first, in the first step we have CHCl3 in basic medium. What will happen to CHCl3? We will get something like negative charge and H2 formation would be there. Okay, so next step is actually the RDS, or the redetermining step, wherein Cl minus will leave the carbon and carbon will be left with carbene. Okay, so in the second step, what actually happens is we have the phenol group, and the phenol group, from the phenol group, OH minus takes off the hydrogen atom, so we get O minus. Okay, this O minus brings its lone pair to the in the resonance with the conjugate pi electrons, so we'll get something like this. Okay, so on this negative charge will actually attack on this carbene to form something like this product, where we have something like C minus, Cn and Cl. So till now carbene was having this orbital configuration. This is 2s and this is 2p orbital. We'll be having something like this. Okay, two free radicals, or not free radical, two electrons, two unpaired electrons. So what will happen next is this minus charge would be actually then giving its electron, as well as giving its electron to this carbon atom and forming a bond between itself and this carbon atom. So what will happen is we'll get something like this as the configuration, in which all the pink colored electrons are the original carbon electrons, the carbene electrons, the carbene's carbon electron, and these two electrons are given by this carbon atom. One is the bond pair and one is donated. Okay, so we get this structure. Next, what will happen is so we have a hydrogen atom also here, so it will form a bond here. This carbon atom and this carbon atom will form a bond here, and this negative charge will attack on this hydrogen atom. Okay, so we'll get again and as this carbon atom forms a bond with this carbon atom's bond pair are taken back by oxygen atom. We'll get something like this, and CHCl. Okay, so now what will happen is, again in the presence of aqueous KOH, or rather NaOH, we get something like they actually attack. The OH minus actually attack on this carbon atom. As a result, Cl would leave this carbon, and we will get something like this O minus, and we'll get and Cl here. Okay, again what will happen is, again OH minus will attack on this carbon atom, and Cl minus will be the leaving group. Okay, so we'll get something like this. Okay, next what will happen is dehydration of this water molecule will happen from the compound at 60 degrees Celsius. Then we'll get something like an O minus, and at in the second step we are passing some acidic medium, so this H plus would be attacked by O minus. We'll get something like this structure. Okay, this is the final product. Okay, so let us now discuss the characteristics of this reaction. So first characteristic is obviously First write this characteristics of reaction. We would have something like carbene will act as an electrophile in this reaction. Okay, second point would be it is a electrophilic substitution reaction. Okay, third point would be molecular weight of phenol increases by 28 in this reaction. Okay, why 28? I think you guys can figure it out because of the attached CO group. Okay, so molecular weight of phenol increases by 28. And how is this becoming possible? I'm just drawing it for some of you who are thinking it should increase by 29. No, the answer is still 28. Why? Because and the position of H here we are replacing it with CHO. Okay, so this H's molecular weight was already there in the present compound. Okay, and this is a new compound in which only C and O atoms are included or getting attached, so molecular weight will increase by 28. Okay, fourth point is carbanion and carbene is intermediate in this reaction. Okay, carbanion and carbene are intermediate in this reaction. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing abnormal Reimer-Tieman reaction. Okay, so till then, good luck and goodbye.